Hey guys, welcome back to Rotor Riot. We're gonna slow it down today.
And we're gonna measure the pitch of that propeller. That's it right there. See that?
You just learned something. You got smarter. Check out this purple drone. We built it in another episode. If you want to check that out, check the description. Today, we're going to be walking you through all the configuration and setup. And you're gonna need a few different programs. Again, there'll be links to all those things in the description. Most importantly, you'll need the Betaflight configurator and BL Heli. Something that is really important when you are working on programming these things, that a step that you do not want to skip, that you don't want to take lightly, is remove the props. I'm being totally serious here. Do not start flashing and messing with these things with the props on. You can hurt yourself, you can damage your computer. It's happened. Just don't mess around with that stuff. Remove your props. It does not take long because we are going to be calibrating ESCs, and if you do one thing wrong, or if there's a little hiccup in the software, or anything doesn't go perfectly right, you can catch a drone to the face. Okay. Props are off. We are now clear to plug in the USB. So I've opened up the Betaflight configurator, and since this is a brand new board, there's no reason not to flash to the newest version of Betaflight. So go to the firmware flasher. We need to make sure that we've got the USB input selected up here. And now this board is the DYS F4 board, which runs Omnibus firmware. So we're going to select Omnibus, and then we're going to choose the newest version, which right now is 3.1.7, but new versions are coming out constantly. Oh, and make sure full chip erase is selected. That will just wipe out any existing configuration. Again, new build, there's nothing on there that you should need. Load firmware from the interwebs. It's downloading, and we are good to go. Flash firmware. Now we wait. Programming successful. Okay, now we can start the fun stuff. We're going to click up in the upper corner, connect. And we can see that as long as we're on this welcome screen, the image is not sitting exactly flat. So we're going to go ahead and calibrate the accelerometer. So hit that. Don't touch the table. Don't touch anything. Let it do its thing. Okay, and now we can pop down to ports. And if you recall from the build video, we walked through connecting the different components to different UARTs on the board. We connected our receiver to UART 3. So we're going to click in the UART 3 row, Serial RX, which will check that box. And then in UART 6, we're going to go over to the peripherals column. To UART 6, we connected the telemetry wire of the Tramp video transmitter. In this peripherals drop down, we're going to select IRC Tramp. This is going to enable us to do some pretty cool stuff through the OSD that will control the video transmitter. So with Serial RX selected for UART 3 and Tramp selected in the peripherals for UART 6, we're going to save and reboot, reconnect, and now we can move down to the next tab. So we just did ports, now we're moving one down into configuration. We can check the setup tab to see that when you move the nose down in real life, the nose of the model moves down, and that the roll matches and yaw is okay. So back in the configuration tab, we don't need to adjust any of the board and sensor alignment. You need to do this if for some reason you've rotated the board, flipped it upside down, or rolled it 90 degrees to get access to the USB or whatever. But with this particular board, everything's been laid out so that with it facing the right direction, you've got access to the USB. All the wires are where you'd want them to be, so we are good to go the way it is. The next area we're going to work on is the receiver. So we set up UART 3 to be a serial receiver. So already it has serial-based receiver selected in this dropdown, and you would use this for Spectrum, S-Bus, or any of these. But we are using Spectrum, and we have two options, Spectrum 1024, that's for DSM2, but we are using the newer, faster DSM-X, so we're going to select Spectrum 2048. We're going to pop down. Here's where we can configure the speed of the system. This is an F4 board. It can operate really quickly. We've got some new fancy fast ESCs, so we're going to update the gyro at 8 kilohertz. We're also going to run the PID loop at 8 kilohertz. I like to leave the accelerometer on. A lot of people turn it off, but the reason I like to leave it on is so that I can still have an auto level mode on a switch, and that can act as somewhat of a fail-safe. Maybe you lose video, or if you completely lose orientation, you can quickly flip that switch and know that your quadcopter is going to align itself horizontally. With the processing power of an F4 chip, there's no reason to turn off the accelerometer, so leave it on. Down here we have a section for other features. By default, the Omnibus firmware comes with the black box feature enabled and the on-screen display feature enabled. And that's all you really need. If you're going to do something fancy like addressable LEDs or something like that, you can check that here, but we are good to go. We're going to go back to the top on the other side. ESC motor features. We can pick our ESC and motor protocol. These are DYSXSD 30 amp ESCs. That means they support D-Shot. The default selection is 1-shot 125. That was once the latest and greatest ESC protocol, but we're going to run the fastest D-Shot available, which is D-Shot 600. We've got battery voltage checked, which means that the board is going to monitor the battery voltage. That's good. And now we're going to check current sensor. That's going to enable us to look at the current drawn and the milliamp hours drawn on the OSD. We're not doing anything with GPS. We're not going to be doing anything 3D today. We'll just name our craft. We'll just call this Dribs drone. And now, save and reboot again. So everything we did in the configuration tab has been saved, and we're going to reconnect to the board and move on. The next thing after the configuration tab is the PID tuning tab. There is so much to be said about PID tuning. I don't want to cover it in this video. I just want to run through all the basic things that you need to configure so that it can fly. And PID tuning is like a whole nother subject, and really something that you shouldn't be doing on the bench, that you need to do out in the field and see how the quadcopter responds to changes that you make to the rates and to the PID. So we're going to move right past that to the receiver tab. What we have installed is a Spectrum receiver. So we are going to go to the channel map drop down, and we're going to select Spectrum. And now we're going to save. This receiver is not actually bound yet though, so we need to do that before we can do anything else on this tab. There's a couple ways to bind Spectrum receivers. With this one, you could actually use a bind plug with the harness that it comes with, but we've already got it directly soldered to the flight controller. So we're going to use Betaflight to force the receiver into bind mode. So we're going to jump all the way down to the CLI tab. First thing we're going to do is type in get Spectrum, and that's going to show us what the Spectrum specific commands are. And we've got Spectrum sat bind and Spectrum sat bind auto reset. First thing we need to do is change the auto reset from 1 to 0. Just type in set Spectrum sat bind auto RST equals 0. And now the next thing that you need to do is type in set Spectrum sat bind equals 9. A value of 9 will force the receiver into a bind mode for DSMX protocol, which is what we want to use. So we're going to hit enter on that. And now with both of those command values changed, we're going to hit save. And when we apply power, the receiver should go into bind mode. Unless we need to, oh my gosh. This is one of the biggest, you're seeing the truth behind binding Spectrum things. This is a pain in the butt. We're going to disconnect the USB so that the flight controller is completely unpowered before we plug in the battery. Now we're going to plug in the battery, and the receiver's still not going to go into bind mode. That should have done it. Why is that not doing it? I'm a little frustrated. We keep trying to get Betaflight to put the receiver into bind mode, which I've done before. And sometimes it works splendidly, and then sometimes it just says no. And tonight's one of those nights is just saying no. I don't know if it's the specific firmware version for Betaflight or if Spectrum, I don't know what the deal is. So we're going to fake a bind plug. The SPM 4649T receiver comes with a harness that lets you put in a bind plug, and that's one way that you can bind it. But if you've already cut that harness, you can just attach the signal wire to a ground pad, and by doing that, the receiver will go into bind mode when it is powered on. All right, we've got the signal wire for the receiver attached to a ground pad. Now when we connect this, if this doesn't go into bind mode, the world hates me. And we are binding. Okay, we're gonna turn on my transmitter, select the model that I want to bind to. I've already got one set up for Betaflight. Make sure to go into the frame rate and make sure that 11 milliseconds is selected. You'll get a warning that you have to use digital servos, but it's a drone. We ain't using servos, so this will reduce the latency as much as possible. We're going to pop down to bind.
Angle mode, throttle cut.
Select bind, and now we're going to get good separation between the receiver antennas and the transmitter antennas. Hit bind.
Binding. Bind failed.
And murder everyone. Unplug. Bind mode. Get better separation all the way back here.
Binding. DSMX 11 milliseconds.
That's what I like to hear. Okay, we can unplug all the things, move our signal wire back to the spot from whence it came, and get back to what we're supposed to be doing, which is basic Betaflight setup. When we were attempting to bind the Spectrum receiver, we tried to do it in the CLI command bar, and we changed some of the values. Even though we weren't successful, we need to go back and put those values back to where they were. So if you change those values, even if you ended up having to bind by putting the signal wire to ground, make sure to go back and put them to where they were before we tried to bind. So get Spectrum set. And as you can see from before, we have Spectrum sat bind set to 9 and Spectrum sat bind auto reset set to 0. So let's put that back to set Spectrum sat bind equals 0 and set Spectrum sat bind equals 1. And save. And we'll double check that that worked. Get Spectrum set. Yep, all good. And now it is guaranteed that the receiver won't go into bind mode for any reason. So with everything bindulated the way it needs to be, we're going to get back to the receiver tab. We're going to make sure that the correct channel map is selected. Yes, TAER1234. Everything looks good. This particular board requires the battery to be connected for the receiver to have power. Some of them will power the receiver off USB, but this one we got up. And now on the screen, we are getting a response from the sticks. What you need to do in your transmitter is make sure that within control setup, you adjust the travel so that full stick movement goes from 2000 to 1000, as you can see as I'm moving roll back and forth on the screen. And then you'll also need to reverse some of the channels to make sure that everything moves in the correct direction. So when you move roll to the left, the bar should move to the left, right should go right. Same with yaw, left is left, right is right. Pitch, right, because by default, this is a perfect example. So we talked about this. Remove your props. Aren't you glad we did this? Poor cameraman almost lost an arm if I wasn't responsible. I forgot that by default, arming is done by yaw to the direction or whatever, so disarm. There we go. At least we know the motor spin. Anyway, as I was saying, throttle down, bar goes to the left, throttle up, bar goes to the right, and then you can assign channels and stuff like that to your preference. Everything looks good in the receiver tab, so we are going to move on to the mode tab, and I'm going to need the receiver to still have power to configure this best, so battery is going to stay connected. And first off, let's fix the problem that would have, cost our dear cameramen some skin had I not been responsible at the props and change how this copter arms. So like I said, by default, you do it with the yaw command. We are going to arm using a switch. I have got auxiliary 2 assigned to this switch, which I like for arming. So we are going to select auxiliary 2, and then we are going to move this bar to accommodate this indicator when it's in the position for which I want. So all right, I'm going to move the switch down. You see the yellow tick mark moves over here? Move this bar over here. Now, whenever this tick mark is in this bar, the copter will arm. So I'm going to disarm. We're going to hit save. We're going to move that tick mark into the zone again, and we are armed. Disarm, arm, much safer than yaw arming. Next, we're going to do our flight modes. Add range to air mode. I've got all my flight modes set up on this switch. All the way up is
Air mode.
So we're going to move this bar so that that tick mark lines up. All the way down,
Angle mode.
angle mode. Move that like so, and you get the idea, and you can configure the other functions and modes to operate with the switches you want, like the OSD switch you could put on maybe aux 3, and so when I move this switch, it could turn off the on-screen display. But I want it on all the time, so that's all we're going to do in this tab. And actually, I'm going to turn on anti-gravity.
Air mode.
That new anti-gravity, though, that means your quad just goes to the moon. And save. Okay, we're going to take a break from the Betaflight connector, so I'm going to disconnect, and I'm going to open up our BL Heli configurator, and that's going to help us get our ESCs set up with everything that we need. We're going to select USB in this drop down, connect, and down here we're going to hit read setup. It's going to tell us everything that we've got going on. While we're in here, let's check for a new version of firmware. We're going to click flash all. There is a new version out. We're going to go with 16.6. We're currently on 16.5, and we're going to hit flash. And now I get to wait again. Okay, with the newest version set, the next thing we need to do is change motor direction. So let's check that. We need to disconnect. Okay. And now we're just going to arm and idle the motors. And now we can just feel the direction that they're spinning. We want the props to spin inward, front and back, so we can grab it. This one is spinning the correct direction. That's going to lead me to believe that motors 1 and 4 need to be reversed, so let's check. Yep, 1 is going the wrong way, 4 is going the wrong way, and 3 looks good. Disarm,
Throttle cut.
reconnect for ESC1. We're going to change normal to reversed. 4 needs to be reversed. And right setup, disconnect.
On.
Good, good, good. Good. All right. We're going to leave the BL Heli configurator, disconnect the battery, get back into Betaflight, and we're going to get to our next tab finally, which is the motors tab. This is the part that freaks everybody out, which is calibrating the ESCs. This is something that is critical if you are using an analog protocol like one-shot or multi-shot. But for D-Shot, which is a digital protocol, you don't need to do this step. So the big scary step, you get to skip. So we're going to run right past the motor tab into the OSD tab. This is where you can configure everything that you want to show using the Betaflight OSD. First off, I'm going to change the video format to NTSC because that's what we're using for the camera and video transmitter. And I don't really want any of this stuff. I don't need to see my fly mode. Fly time will keep, on time no. I don't want these sidebars. I don't want these horizons, and now we'll just, okay. I'm gonna grab the voltage readout up here, put it in the corner where I like it. I wanna see my current draw, put that over here so I can see how many amps I am currently ruining the battery with. And then I'm gonna grab the milliamp hours drawn so I know along with the voltage when I need to land. Just arranging everything exactly where I want it, and we're all set. Save. And now everything should be good to go. Last thing I'm going to do is set the idle for D-Shot. So what I'm going to do is figure out the minimum command at which the motors all spin smoothly. So we're in the motor tab. We've checked that I understand the risks of spinning the propellers on the bench and that they are removed. And now we're going to slowly move this master slider up until we see them all spin. And they're all spinning at 1013, which would translate to 1.3%, but they're not quite as smooth as I'd like them, so I'm going to bump it up until about, they're sounding really reliable at 1020, which would be 2%. So we're going to shut those off. We're going to disconnect the battery, go to configuration, and set the motor idle throttle value to 2% is what we saw, but I'm gonna add in another 0.5% for an extra buffer zone so that I don't get a motor stalling in the air, because that can get you a little bit of wonk. Save and reboot. Everything should be good to go. Let's put the props on and do an indoor hover test.
Throttle cut.
Am I as cool as steel now? Last thing are some secret stuff. This is serious business! Stop! Stop! You're ruining the high! I'm like a cat now. I'm upset. I'm just gonna get up somewhere high. Alright, we're gonna go to the CLI tab. Earlier we talked about leaving the accelerometer on and why you might want to do that. One disadvantage is that you cannot arm your quad unless it's sitting flat. So let's say maybe you get stuck in a tree and you want to try and shake yourself out. You're not going to be able to do that with your accelerometer on unless you know this secret command. It's called small angle. Get small underscore angle. Currently it's set to 25. That means that if the quad is tilted more than 25 degrees in any axis, it will not arm. So we're going to set small angle equals 180. That means even if it's upside down, you can still arm it. The other thing that we're going to set here is a command called min check. Get min underscore check. The default value for min check in Betaflight is 1100. So what that means is if your transmitter is sending a signal below 1100, Betaflight ignores it. And what you end up with is a little bit of deadband at the bottom of your stick travel. What that's there for is because some transmitters may not be able to reliably deliver a low command. So if it was set to the minimum signal that Betaflight uses, which is 1000, you might not be able to arm your copter for some reason. Your transmitter is bottoming out at 1010 or something like that. So in the receiver tab, you can check what is the minimum command that your receiver will reliably send and set it to that and just maybe a little bit of headroom. I'm going to set min check equals 1005. So that means we're going to have a very minimal deadband, and I saw in the receiver tab that I was always getting really close to 1000, maybe even a little lower, 999. But either way, 1005 will guarantee that I'm able to arm, and it will minimize the deadband that I have at the bottom of my stick travel. So with our min check set and our small angle set, we're going to save. If you're having trouble with arming or anything, just set it to something higher. When I'm moving fast, I usually just set it to like 1025, and then there's still a little bit of deadband, but it's not too bad. Thank you guys so much for checking out this video on configuring your Betaflight board. I hope you learned a little bit about how to get everything set up and all the cool features like OSD. Anyways, I'm tired of being stuck down in this basement. I am ready to rip this thing, so I'm gonna go do that right now. It's fly time. What
if I want to leave my props on?
Then you're gonna die. You're gonna die and you're gonna ruin the hobby.
Okay.
Freaking Chad always wants to ruin the hobby. Just go dive some buildings and leave our props on. Wow.
I have never dived a building.
This is true. You're an instigator. You don't actually do anything. You just tell other people to do the things. Fly something, Chad. Jeez.